Hi everyone, very good evening. I would like to welcome you all for today's webinar, Sheetmetal Inside Inventor. In this session, we're going to discuss various sheetmetal features and other tools that is available inside Inventor and how we can use those tools to create our own sheet metals. And today's agenda is like how we can set up and manage Inventor sheet metal styles and rules. In the Inventor or any software, no, before we going for a sheet metal design, we need to instruct the software what are all the set of rules that it has to follow for either for bending, or if you're going to unfold the sheet metal, or if you're going to unblank, or whatever may be the thing that you're going to do with the sheet metal. We need to define some set of rules and styles before you are going to design this sheet metal features. Okay, so we're going to see that one, how to set up and manage Inventor sheet metal styles and the rules, how we can do that inside Inventor. And next we're going to see uh, various sheet metal features and how we can use those features. Okay, and finally we're going to see how we can convert a standard Inventor part to the sheet metal. Uh, so not only that limited to Inventor standard parts, even you can bring other CAD files into your Inventor, and you can convert those CAD files to a sheet metal. Okay, so we're going to see these things in detail. And first, we're going to just discuss how we can set up the sheet metal rules, and how we can create a bin tables and those things. Okay, right. So before moving into that one, so this session will be useful for those who are a control panel manufacturers or SPM manufacturers, where mostly their machine outdoors and indoors mostly made up of sheet metals. And if you take this control cabinet and out all your outer shells and everything is made up of your sheet metal. Okay, so not only with limited to this thing, there are wide range of application for the sheet metal. So for those kind of manufacturers, this session will be very helpful. Okay, right. So when we can choose the sheet metal, so you know, if you have a uniform material throughout the entire design, and if you have the uniform thickness where it requires, bending and folding, so that is where your sheet metal comes into this application. Okay, and you can see it will be having uniform thickness throughout the area. So where this is where we used to choose our sheet metal. First, let us get into this Inventor sheet metal styles and rules. And here we're going to discuss how we can set up the sheet metal rules, and how we can define unfold rules, and how we can share styles or that rules with the templates. Okay, so that we don't need to create these styles and rules again and again. We can even save this one as a template, so that we can also share these templates to other users. So it will considerably reduce your overall time. Okay, so where we could able to find this sheet metal styles and rules. So if we get into inside Inventor, where we will have style and standard editor. So if we get into this dialog box, where we will find how we can define your sheet metal rules, and how we can define the unfold rules. So it will give you a nice feature where we could able to give multiple rules sheet for your sheet metal rules, that may be based on the thickness and with different materials. Okay, and you can also define your unfold rules, and you can go for either pin composition, or you can go for the K factor, or you can go for based on different set of equations. Okay, so this is available inside your styles and standard editor. So what we're going to see, so within short time. And so what are the sheet metal rules? Okay, so if you take these sheet metals, it has some set of rules where we can define its material and its thickness and its unfold rule. And once if you're going to bend your sheet metal, if you're going to bend your sheet metal, where we need to provide what is the radius, in which radius it has to bend, and when it bends, and what is the relief it has to take, and how it has to transition. So this kind of bend rules we need to provide while we going for any flange, or if you're going to bend your sheet metal. Okay, so these things we're going to see how we can provide inside your inventory sheet metal rules. And finally we're going to see how we can set up the corner. Let's say if either two or three sheet metals interact with each other, where we will be having the relief. So how, what type of relief shapes is required, and how we can set the radius, and where we need to place this relief placements. So these things available, and we're going to see how we can use these things, based on your own manufacturer requirement, or based on your own client requirement, how we can set up these things. And so if you take the sheet metal rules bend, where we can also able to provide straight corners and other relief shapes. So let us just get into the inventor, and let us see how we can set up all these things. Okay. So to get into the stand sheet metal, if you open inventor, you will have two things. Okay, one is the standard part, and next is the sheet metal. Okay. Before that, you just make sure you have set your project in a particular unit, that may be either in inches or mm. So now let me get into this sheet metal, and let me create a sheet metal. So once I click it, you can see the difference. Okay, so maybe if you have gone for a previous or pot modeling session, you can easily find the difference. Your sheet metal interface maybe look different than that of the normal pot interface. Okay, here, as I told you, before getting into our sheet metal design, we need to define the sheet metal rules. Okay, so to set the sheet metal rules, we used to go to this sheet metal defaults, okay, in this setup tab, where we will be defining all our rules. So let me click that, and here you can see your sheet metal rule and your materials and your unfold rule. Here, if you come here, you can see some pencil symbol. No, just click this one. It will directly take you to this styles and standard editor. Okay, where we used to set up the things that whatever I told you. So here you can define default and default mm. So default basically in the inches, and default mm. So if you want to create your own new styles based on the thickness and based on the materials, you can easily create it. So let me create one. So you can right click in the styles, and you can go for new styles, where I can set, let's say, 2 sheet. Also I can create another sheet, let's say 5 sheet. All right, so like this I can create multiple sheets with the thickness. So now I can go to 2 and I can change my thickness to 2 or I can change my materials. Okay, so that's how you'll set your sheet metal rules here with different thickness. Now so let me just, I don't want to use this, let me purge the style. Okay, and if you go to this default here also you can able to set your default thickness of your sheet metal. And next, here you will find sheet metal unfold, where it will give you many methods to unfold your sheet metal. Okay, so maybe first one is based on bin composition, where we can see different set of equations, and next you can find your default k factor. Okay, so first let us see this one, and what we got within this default. And here you can see three tabs. Okay, one is based on the sheet, and next is for your bend, and next is for your corner. So in this sheet we used to set our material, what type of material it is, that may be mild steel or maybe aluminum, or what type of material that we're going to use. Next we will be setting the thickness of your sheet metal. Okay, so in this case let me take for example 2 Okay, so that is the thickness, and we can also set your bending angle, and we can set your punch patterns. Okay, uh, So next, if you go to this bend where we can set your relief shapes, whether you want round or tear, and can also set your corners. So let me quickly take you to the this area and let us see how it will work. So I'm just creating a new sketch. So it's a way first we will start with the sheet metal. So once we define your sketch, we can directly go to this face option where whatever thickness that we gave inside in this default mm, it will automatically create a face for you. Okay, and you can see so we are given 2 mm thickness, and if you measure this thing and you will find we will have a 2 mm thickness sheet metal, right? So now what we're going to see how what is this bend as well as this corner, how it applicable to Inventor sheet metal. So let me go to this flange and let me create a flange here. Let me let's say offset. Let's create okay, and let me go to this flange here and let me go to this edit feature, and in this bend rule let me change that one to let's say tier. Okay, and you can see the difference. Okay, and let me go to this flange again and let me change that one to, let me go to bend and let me go to let's say straight, or in this case let me increase the thickness length, let's say to 100. In this flange let us let's go to let's say 50 mm and let me give okay, yes, this is what we need. So now you can go to this flange and edit the future, and you can go to this bend, and here you can see something, right? What is this one? This A is nothing but your bend relief width, okay, and this B is nothing but your relief depth. So here my A is this depth and my B is this case my width. Okay, so if you want to control these parameters, you can go to this edit feature, and in this bend value you can, so this is the default values that is already available inside your Inventor. Let's say if you want to change this width, let's say instead of 3 mm I want 5 mm. Let me click this one. You can see the difference. That is my previous one. So once I able to adjust my width here, okay, and so let me just for the default value. Next, my relief depth. So here you can see B parameter is B here. Okay, so if you want to change that, let me give let's say 5. Let me click OK, and you can see there is slightly increased value in this depth value. Now we can see the difference. Okay, so in that way we could able to control the this relief values, and if you want to change this relief shape, okay, where we get went for straight, let's say if you go for tier, and you can just see how it is looking here. Okay, this is your tier shape of your bend, and so if you want to go for round shape, and you can see it will nicely create your bend, round shape in the where your bend comes. Okay, so it is one of the way, and next we will see how the corner features are applied inside your Inventor. So let me create two new flanges at these corners, and you can see how these corners are. So if you want to edit these corners, so after your bend you can find something called corners here. Okay, so here you could able to let's say you can go for, if you want this round shape you can go for this round, or if you want to go for other features where instead of round, let's say I want to go for linear weld where I could able to apply my welding. So you can go like this. Uh, if you want to go for, let's say, a square, you could able to create a square shape here. Okay, so we could able to control the corner as well as the bend futures based on either you can set those things in your sheet metal defaults, or if you want to customize this thing based on different no different flanges, you can directly come to this flange, and here you can change your bend as well as corner relief depths. Okay, so this is what we used to control uh, in the standard sheet metal rules, where you have sheets, bends, and your corners. Okay, and next we will see the unfold rules. So what we see in this one, right? Bend as well as the corner. So where we will be having different relief shapes in the corner, maybe round, square, as well as for arc weld and like this. Now let us go for this unfold rules. Okay, so what are this unfold actually? So when you go into no, once you bend your sheet metal, if you're going for any folded model and you want to unfold the sheet metal, okay, let's say you're going to unblank the sheet metal, and what is the rule it has to follow. So okay, when let's say if I just bend this one, you can see there is some bend composition applied to this one. Okay, so that bend composition we will call based on our K factor. It's vary based on the manufacturers that we are going to deal with. Okay, so in Inventor it gave you three methods of specifying this bend composition. So one is based on the linear K factor, and next is based on this bend table, and third one based on many custom equation. Okay, again here you will have four methods based on bend allowance, and based on bend composition, and based on bend thickness and variable K factor. Okay, so let us see one by one. First, let us understand what is mean by this K factor. Okay. So K factor is the ratio of location of the neutral surface to the material thickness. You can see here. Okay, so this value you can see here. So that value is based on the K factor. So what is the K factor? And this comma by mu, right? Where my mu is the thickness, and where my comma tells where my neutral axis resides. So mostly this comma is measured from the inner face of your sheet metal, and mostly this value between 0 and 1. Okay, so if your value is nearby 0, so which means you could able to easily bend your sheet metal, and if your value moves towards 1 where it's very difficult to bend. So even if you take with respect to materials, if your value, let's say if your value is 0.2 or zero point 0.3, mostly it is applicable to soft materials, and if your value moves towards closer to your one, where you can directly go for the where we will be using those values for harder materials. Okay, uh, again these values and these things will be given by our own manufacturers. Okay, so this is what about this K factor. So the way of this K factor we could able to represent in the different ways. Okay, and and next based on the equation, so if you want to calculate this unblank length, okay, where you know L is the total unblank length by what I will get once I unfold this sheet metal, and this is the L1, and you can see this is important, this LBA, bent allowance. Okay, what allowance we need to give. So if you want to calculate for this sheet metal what is the LBA that we need to give, and this is the formula. Okay, for LBA is equal to pi beta by 180 and rho plus K factor into mu, where mu is the thickness of your sheet metal, and rho is the radius, bent radius, and my beta is nothing but my angle. Okay, what is the angle of my flange? So with this, we could able to calculate our bend allowance, and finally, so with all these inputs, we could able to find the unblank length. Okay, and this is a typical example where we can see my L1 is 2.0 7 and my L2 is 2.2 and I'm having thickness of about 0.2. Okay, my bend radius is 0.5 and my angle is, let's say here, beta, and my this is my rho value, and you can see in this formula. Okay, my rho value and my mu is the thickness and my beta is the angle. So from this, what I will get my total unblank length. So once I calculate my bending allowance, okay, my pi into angle divided by 180 into my radius. So this is my formula. So I'm just getting after applying the formula, and what is the total unblank length I'm getting? 5.538. Okay. So in this way, we could able to calculate the total unblank length of our sheet metal. Okay. The other way of calculating this one is using bend table also. So why we use this bend table? So it is this length correction value for a specific material thickness, a specific radii and bend angle. Okay, you can see two things. One is your bending radii and next is your angle. Okay, so based on these two things, we will specify the length correction values for each and every material and thickness. Okay, so it may vary based on different angles. You can see for one and for 0.125 radius, there is some correction values, and for 50 angle and for 4 radii, bend radii, there are other no correction length correction value. So these things we can give as a table, and we can import that inside this table. So we can instruct the uh, inventor how it has to take when it moves from when it take this value and this radius, so that automatically this uh, length correction value automatically applies. So that length correction value automatically minus from the deducted from your total correction total unblank length. Okay, you can see L is equal to L1 plus L2 minus gamma rate, where my correction value will come into place. And apart from your bend table, you will also have this custom equation where you will have bend elements, bend composition, bend detection, variable K factor. And you can see the custom equation based on different types: bend elements, bend composition, my bend detection, and my K factor. Okay, uh, and finally, once we did this, we can able to save. We can save that one as a template, and we can use it uh, uh, many times, or we can also share that template to other users. So let us see how it will work. So the unfolded that what I'm talking about is available inside your sheet metal default, and if I enter into this sheet metal edit, uh, here you can see your unfold rule. Okay, so you will have bend composition as well as default K factor, and let me just click this pencil symbol where you can see these unfold methods. So whatever we have just seen, okay, K factor value where the default value is 0.44. Okay. And if you just enter into the next one, you can see this bend table where we could able to go for different set of bend tables, and we can use the values here. And let me just show you one bent table here. And I'm having my bend table in my text format, and let me show you how it look like. Okay, and my correction value is minus x, and it's unfolded length. Okay, so all this thickness and radius value has been in my text format. So I could able to import inside my table bend table, and I could instruct the software how it has to follow when going to apply this value and this radii. Okay, now let us go to this bend table, and I'm going to this import option. Okay, I'm going to import the text file to my bend table. So where you can have different types of files. Okay, and I'm going for text, and I'm just going to select this bend table, and I'm going to open. Let me give that, and you can see once I import that one, and So what I get from the manufacturer is like based on different thickness. One is based on 0.5 thickness, and next is based on the 2 mm thickness. Okay. And you can see my open angle. So here again you can define two angles, okay, bending angle reference or your open angle reference. And here the left hand side values represent your angle values, and this horizontal value represent your radii values. And the values which is here, that is the your length correction values. Okay, uh, that will either get minus or that will be get added to your overall blank length. Okay, so that is about my bend table here. Okay, so it's based on different thickness. And next you will have based on your custom thickness. And here you will have different equation types. One is based on my bend elements. Okay, where you can see this one, L is equal to L1 plus L2 plus alpha. And next is based on the custom equation, sorry, bend composition, and that is my view. And the third one is based on my bend detection, and finally is based on my K factor. Okay, so these values I could able to customize my unfold method by using this custom equation. So again, it depends on your manufacturers and how they want on based on whether they want based on bend detection or whether they want based on bend allowance. Okay, so we can instruct the software how it has to unfold by based on different set of values that we're going to input. So that's about your sheet metal set rules and unfold rules. So that's how we can able to set up before getting into any design. Okay, so once we set up these designs, what we can do, we can directly take this template. I can go for save as, and I can save this as a save copy as template, and it will directly take you to my template library. I can save this one as a let's say I can give that one as a, let's say, new sheet. Okay, now if I get into my template file, directly you can see there is something I'm getting is like new sheet. Okay, so that I can able to share this template to others, or I can able to use this sheets with this sheet metal with the defined set of rules. Okay, so that I don't need to change these things again and again, right? So that is one way of setting your sheet metal rules before getting into any designs. Okay, now let us see the sheet metal features, and so far we've seen how to set the styles and rules. So if you take the sheet metal features, where we will have base features as well as the secondary features. So base features like face and your counter flange and lofted flange and counter roll. This is your base features, and this is we will be designing this one before going for the other features. And the secondary feature we have with sheet metal is like flanges and bend, and you can see this from your inventor, your punches and your cuts, and how we can unfold and refold. Now let us just quickly see what are all the features in the inventor sheet metal. Uh, so we have seen how to create a face, how we can create a face. I think we have already saw. So now let us go for other tools, how we can able to create this counter flange, we can able to create this counter roll and these things. And so first we have to set defaults. So once we set that, we can directly go to this modeling tool. Let's say I want to set this face. So we have set this face, and let me show you how I have set. So based on the my sketch, I can directly go to this face, and I can select my face, my sketch, and automatically it will create a face like this. Okay, next I can go to this counter flange. This counter flange works based on your defined sketch. Okay, so that is my sketch here. So it will directly select your sketch, and what we need to select is like we need to select the edge. So based on the edge, Okay, so if you go to this counter flange, that's my sketch, and I can able to select my you know edge of my sheet metal. Okay, so based on my sketch, that sketch should be always a normal to your face. Okay, so that it will directly take your edges like this. Just trying to take this one. See. Okay, and you can see your counter flange. Okay, so whether you do, again, you don't need to create multiple flanges here. Directly from the sketch, your counter flange, you'll get your counter flange inside your inventor. Okay, so next we will go for no, the slaughter flange, and I'm going to create a flange between these two sketches that I've already defined. Let me get into that one. So let me select this sketch and this sketch. So it will create a lofted flange for you, and again you will have two options. Maybe one is for smooth, and next you will have based on the convergence. Okay, and so once you create your flange, and if you want to go for any counter roll operations, okay, so where I already defined my center line, let me go to this counter roll and let me select the sketch, and here my axis is, that is my axis. Okay, and you can see it has created my counter roll like this. Okay, and I can able to specify my thickness, sorry, my angle. So if whether I want in 180 or I want in, let's say, 270, I could able to create like this. Okay, so where we have seen our counter flange, and we have seen the face operation, we have seen how to create this loft, and also we have seen how to create this counter roll operation. So that is my base features that we have saw, and we will go for other secondary features quickly. Okay, uh, yes, let's say if you want to create a bend between let's say these two sheet metals, we can directly go to this bend, and here I can able to select my corners of these two sheet metals. Okay, so it automatically creates a bend between these two faces. Okay, let's say if you want to unfold a sheet metal, you go to standard sheet metal. Let's say if you're going to unfold a sheet metal based on the folded line, that what you're going to specify. So I'm just representing my bending line. Okay, so my sheet metal has to bend based on this bending line. Okay, so I can go to this fold and I can just select my folding line. Okay, delete that. Let me just go again. Let me project these geometries. Okay, so my bending line has to touch both the edges of my sheet metal. And let me just finish this sketch and let me go to this fold again. And you can see once I select my fold, it's asking me to select the direction. Okay, so in which direction I have to fold, and so those kind of controls you could be able to find in this flip control, like this or like that, or another way of bending this. Okay, so where I could be able to give my fold angle and also my bend radius here. So that's how your fold will work. And if you want to give any hem here, this plangent, you could be able to give, or different types of hem you will find, whether it may be teardrop or rolled one, or you can go for the double roll like this. And so again, these parameters, this gap and this length, you could be able to control here. Okay, click OK, and that's about your fold, bend, as well as your hem options. Okay, and one more thing, if you want to cut this sheet metal, okay, so let's say, let me just give one angle here. Sorry, let's say if you want to cut this sheet metal, Okay, so what Inventor provides you is, like, you can see there's something called cut here. I could able to cut like this. Okay, so when I just go for no simply cut, what it will do, it will actually cut the profile normal to my sheet metal. Okay, but here I will have one option. When I go for cut across bend, and you can see what is happening. So it will cut across my bend. Okay, so even if you change your no cut profile, automatically that will adjust. Okay, so based on the cut profile, we could able to cut along to my bend also. Okay, so that is another way of doing the sheet metals. And so if you want to unfold this sheet metal, you can directly go to unfold, and you can just select the folding angle where you want to unfold, and you can click OK, and you can see you can unfold like this. Okay, and again, if you want to refold, so again, if you want to refold this one, you can go to the refold, and you can just select that one, so you could be able to refold back again. Okay, so that is the tools. And so what else we left here? So now let us get into this punch tool. Okay. And so we have other secondary features, like as I told you, we'll have also have punch tools. There are some predefined punch tools that is already available inside your Inventor. Okay, so now let us see how it will work, and let me just place one point here. And if you go to this punch tools, where you will have no predefined set of punch tools. Okay, so let me just take one, and let us see how it will work. And if I just go for this, let's say round emboss, and click open, and where I have given my point, right? So it will directly choose my point, and I can pick different sizes and diameter. Let me just give finish sketch, and you can see it will create a punch like this. Okay, so if you want to go for different punches, and let me just delete that. Place a point again, and let me go to punch tool. Uh, okay, so let us take this one. And so what happens? So automatically, let me just give you the finish. So it will directly cut your profile like this. Okay, so these are my punch tools. Want to create your own punch tool, we could also able to create your own punch tool also. Now let us see how to create your own punch tool. Yes, here you can see this is the one I already predefined. So how I created this one based on my face sketch, and that is my sketch here. Then I went to revolve option, and finally I did like this. Okay, so this is my pen. This is my one of the punch tools. So now how I could able to extract this information, and I can able to create inside my punch tool. Okay, let us see that whatever this punch tool, whatever punch tool you're going to take, everything will be available as a eye feature only. Okay, so let me go to this manage, and here you can see something called extract eye feature. Okay, let me just click this one, and let me just select this features. Okay, so next, here you will have two things. One is your standard eye feature, next is your sheet metal punch eye feature. So here we need to select the sheet metal punch eye feature. Once you select this, and you can see whatever features that we have selected, it directly took those information into this size parameter. And finally we need to select that sketch, and you can see that is my sketch here, and let me just save this one to my catalog. Okay, I can give that one as a eye feature new, for example, and let me save this one. Now let us go for how we can punch this one. Okay. So before giving that, and let me just give some points and where I want to punch. Okay. So let me just, let me give one point here, and that's where I want to punch. So let me go to this punch tool, and let us select this one. So this is what we have created, a new punch. Let me give open, and you can see the lines are in red colors, which means the information is not matching to the uh, your sheet metal rule. Okay, so that we can, now we can go, if you want, we can go and change the size here. So just give radius as at 9 mm, and you can see it automatically creates your punch feature for you. Okay, so if you want to go for multiple types where you can place your sketch, and if you want to change, you can see this my feature, and if you want to change the parameters, you can directly go to this change, and where you can change your width as well as your radius. Okay, so this offset will directly take from the sheet metal defaults. So in this way you could able to set your own punch tool. Okay, and next we're going to just see your flat pattern. Okay, so what is the use of flat pattern? And it's to prove whether your design is valid or not. Once you done your folded model, and we unblank that one, and we no refer, we just refer whether what we did it is right or wrong using this flat pattern. And it also serve the purpose for your manufacturing, where no we could able to give bend table as well as your bend and punch notes, which is useful for the manufacturers. Okay, so let us create a one flat pattern, and let's see how it will work. So that is my flat pattern here. So let me just hide everything. Right, so that is my flat pattern. So sorry, that is my folded model. Okay, so how I can able to create this one as a flat pattern? I can directly go to sheet metal, and I can go to this, go to flat pattern. Okay, so it will directly generate you a flat pattern for you, and so that flat pattern you could able to find in this model browser. Okay, and if you want to take this flat pattern as well as this folded model to your drawing, you can so I already created a drawing. Let me just open this drawing, and you can see this is my folded model, and this is my uh, flat pattern. Okay, where I could able to give my bending information. So let me delete this one, and to give the bending information, you can go to annotate, and you can go to this bend, and here you can represent your bending information. Okay, do your flat sheet metal, and you can see the other stuff information for the folded as well as the sheet metal for you. And also I could able to give that one as a bending table. Okay, where I could able to represent my bending direction, bending angle for different set of bend features. Okay, so that's what my flat pattern is about. And finally, let us see how to convert your standard part to the sheet metal. Okay, and so this is my standard part, and you can see we are in this part modeling environment. Okay, so to convert to the sheet metal, we can use this convert to sheet metal. But before converting this sheet metal, we need to no we need to make sure this model that we're going to cut with respect to, so we're going to use in sheet metal. Okay, so we need to do those kind of operation inside your modeling itself. Okay, so where your two tools are useful here, one is the shell command, and next is your thicken by offset. So I'm going to this shell command, and I'm directly taking the thickness as 0.1 inches, and I'm going to take uh, these faces here. Okay, now you can see that is my inside face, and you can measure the thickness, and my thickness is like, let's say this is my 0.1 inch. Okay, now let me convert this onto my sheet metal. Now once you convert to your sheet metal, and mostly what people do the mistake, they don't set this sheet metal thickness to this rule sheet metal thickness. If these two things differ, you don't get any flat pattern, you won't able to create anything. So first make sure this thickness is matching with this sheet metal default thickness. So the default thickness that what we have seen here is like 0.120, but the thickness that what we have measured 0.10. So let me just give this value 0.10. Now this value is matching with the value of this uh, standard part. Okay, now we can perform the operations that whatever we're going to perform. Now let me go to this corner seam and let me rip these edges. Okay, so this edge and this edge and this edge. This edge also. So let me click OK. Now let me go to this bend and let me just create a bend here. Sorry. So let me rip up to here. And to create a bending, let me go to this bend and let me apply this bending here, here, and let's say here, and you can see a sharp corner here. I'm going to apply the bend here, and finally here also. Okay. So once we given our bend in my rib, now we could able to go for creating a flat pattern. Okay, you can see I'm just getting this flat pattern. So we have created from the standard part and we converted to sheet metal, and finally we took this standard part. So if you want to take this one to your drawing view, you can either place that one as a folded model, or you can place that one as a flat pattern, and here you could able to take your bending information. Okay, like this. So that's how you will convert this standard part to your sheet part. Okay. uh, so I think we have seen many features, how to set the sheet metal rules and styles, and now we can go for this normal features, and also we have seen how we can set these punch tool using this eye feature, and we also saw finally how we can convert this standard part to the Inventor sheet metal. Okay. uh, then I hope this session is useful for you, and so in the we will just meet in the upcoming session, and if you have any doubts you can put your questions in the comment section. Okay, and that's what for today's session. Thank you.